So is everybody okay with the fact that gravity is what's trying to pull? I'm assuming this is frictionless. So let's just play with this and say it's frictionless. Okay, I don't think it said friction. So what is trying to pull that thing down the hill? Gravity, right? And we know exactly how big gravity is, right? So what we know is that the acceleration down this hill is g sine theta. And if that doesn't make sense to you, this is g, right? And then g is broken into two pieces as it goes down the hill. There's g cos theta and g sine theta. So g cos theta pushes it into the hill, the normal acceleration. G sine theta is pulling it down the hill. Does that make sense to everyone? Okay, so what we have to do is create an acceleration in this direction that, so if we look at this thing accelerating down the hill at g sine theta, then if we supply an acceleration to this block to the right, if we push it fast enough, then, well, okay, let me do it this simple way. Then essentially what we're trying to do is, if we say that this is g sine theta down the hill, we're trying to create an acceleration up the hill that's going to match. Does that make sense? So this is whatever, let's go parallel, the A parallel to the surface. And does it make sense to you that this is A, right, the overall part of A, and then A is going to do, to this block, A is going to do two things. It's going to push it that way, and it's going to go like this. Like when I push this forward, if I was just applying A to this block, that's what it would do. But because I'm applying A to this triangle, this block actually feels this. So it's like whatever. Thank you, yeah. A reaction. Do you get what I'm saying there? If we applied the acceleration that we need on this block by itself, it would go to the right. But because we're applying it to the floor under the block, right? It's like if your hand is sitting there and I push up on your hand. Yeah, your hand didn't accelerate down, but it feels as if it was, right? Because the floor underneath you is going. So the acceleration of this block is this block is feeling an acceleration into the surface. You know, like when you get in an elevator, right? So when you hit the button, the elevator takes off. Whoa, your knees kind of do that because it pushed up underneath your feet. Okay, so that's what we're doing here, and what we want is that thing to break up into two pieces. Okay, and if we do that vector there, that means. So if we're saying that it's this way, that's parallel to this, and that, so that means that's theta, that's theta. So that means this is theta? Let me see. Yeah, you're right. This is theta, right there. Okay, does everybody see that? How that's theta? If it doesn't make sense, look at it like this. So this is theta. Here's the block. This is the acceleration that we want the block to feel.
Yeah, other side should be theta.
Okay, so if you see the block, do you see that? Oh, wait.
No, that's 180.
Yeah, because this right here, this right there is theta.
The other angle.
So if that's theta, this is not theta. I was right, right? I think this is 90 minus theta. Does that make sense to you? If you draw this is what we're looking for. This is the A reaction, that reaction acceleration. And if I draw this, do you see like this little tiny triangle up here is the same as the big triangle, which means this angle is theta, which means that angle is theta, which means this angle right here must be 90 minus theta. Yeah, so this angle is theta right there. So if we want to find these two sides, this is going to be AR cosine theta. This is going to be AR sine theta. Does that make sense? And so what we get, essentially, racing slowly. What we get is AR cos theta is equal to G sine theta. So then AR, or this is AR, well, we need AR to go that way, is going to equal G tan theta. So we need to apply a force to this to the right, okay? Did the elevator thing make sense to you? That if I accelerate the elevator floor up into your feet, to you, it's the same as you being accelerated down, like pushed into the floor, right? So like, below your hand, like when I push up, does your hand know that it's being pushed up or that it's being pushed down by some extra gravity force? You see what I mean? Your eyes know, but your hand doesn't know. Just like when you're in an elevator. When you feel the elevator go off and you feel yourself get pulled down, right? You don't know that that's the elevator moving up. You're like, wow, gravity just got bigger for a small amount of time, right? You don't know that. You felt like you're being accelerated down. So we need to accelerate this block up this incline. And the exact amount of this acceleration in this parallel direction has to equal G sine theta. Does that make sense to you? Exactly, right? Very good. And so then how do I get this A sub P, right? This. How do I get this A sub P? Well, I have to move the whole thing. I have to make the block feel like it's being accelerated to the left. And how do I do that? I accelerate the triangle to the right. Okay, because I can't just turn on gravity and make it go sideways. So I push the block, I push the triangle into the block. Oh. Okay. I push the triangle into the block. That makes the block feel like it's being accelerated to the left. Okay, and because it's being accelerated to the left, then a component of that acceleration can match gravity, and when that works, the block stays there. And that's how we get G tan theta. Questions? These are great problems. Oh, yeah, so it's just the mass. So the force that we need is going to be the total mass times A sub r. Right? It has to be the total mass. So it has to be m1 plus m2 times A sub r. Why don't I just do m1? I'm sorry, m2. Right, because remember there's an m1 there, and if I do just m2, then that force will result in a smaller acceleration over the whole mass, and then this thing will slide down. Questions? Oh, because when I divide both sides by cosine, I get tangent. I think that's it, right? We don't know any of the other stuff. So the answer is going to be m1 plus m2 times G tan theta. Very cool.